Hello and welcome to another video. I thought I'd make a, for those of you once again that don't know really much about these custom ECUs, what's the benefit of these systems, and here's a short demonstration of simple stuff that I can show you what benefits it brings. So here on the table I have some old OEM Nissan parts that are from the 80s. These are designed in the 80s and manufactured in the 80s. And here on the right side of the table I have the technology that replaces all of these, and you can control these as you wish, and I'm going to explain also how these are better in many ways. Then also I'm going to describe just a short thing that I want to show you also is this cabling that I'm using for these modern devices. So the first thing of this engine, sorry there's a complete mess, I'm making these wiring looms once again, but first thing I want to talk about is the air that comes into the engine. Now, with these older engines you have a MAF sensor. You have a MAF sensor that goes directly here before the turbo, and it's the first thing totally in your air intake system, and it measures how much air goes through it. But there are many downsides to MAF sensors, such as they are very prone for turbulence. So if the air is kind of circulating inside the MAF sensor, it disrupts the signal. Then if there's any leaks in anywhere of the system behind, after the MAF sensor doesn't know about the air that's getting leaked into the system after it. And then especially with turbo systems, once you hit boost and then your throttle plate goes completely shut, there's still the turbo is still generating boost to this area of the boost pipes, but the throttle plate shuts, so there's a sudden back pressure change which launches all the pressure back to the MAF sensor, and it also thinks the MAF sensor kind of is fooled by that amount of air going backwards and forwards in the sensor, and it thinks that the engine is getting lots of air, and it gives it lots and lots of fuel, and it just spits it out of the exhaust. Then there are some other sensors in these engines. The MAF sensor calculates the amount of air, the air temperature. Then there are some maybe some kind of map sensors and so on. And with an ECU like this one, well, first of all, here is the MAF sensor. As you can see, it's quite big. Now there's the sensor itself, very thin kind of metal wire, and there's a resistance going through it, and when the air that goes through it cools the small metal wire down, it calculates how much air goes past it. Now with these modern engines you only need this one. This is a intake air temperature sensor, and this connected to the built-in MAP sensor in the ECU take care of all of that. And this doesn't care about boost leaks, it doesn't care about any kinds of leaks, it only calculates the volumetric amount of air into your engine by the temperature that goes in, and it doesn't care even if your boost pipes are completely off, you can still drive the car. But this one is not, you cannot fool this one, you cannot kind of disrupt it. Now the second thing that I want to talk about has to do with air also. Naturally, the engine gets air through the throttle body. That's when you accelerate and control the throttle with your feet or the pedal. But then there's another system also how air gets passed to the engine, and that's by idle control valve and additional control valve or air control valve, which are located in the RB engine. The idle control valve gives idle air from here. It has two options, higher rev or lower rev, and it just controls the idle, and it knows when the engine is supposed to be idling by the throttle position. So when the throttle position is, say, lower than 5% open, it knows that it has to control the idle by itself. Then there are additional air control valves which are located in the backside of the intake manifold. And what that thing does, it enriches the fuel air-fuel ratio when the engine is cold, or when it just thinks that the engine needs more air. Like, say, when you have a AC system, that's when the engine or the ECU demands more air for the engine, so that it can kind of rev up and stay running easier. Also, different cars have different kinds of systems. Like in the Supra next to me, the additional air control valve is a bit different. It also helps the engine breathe a bit better when you turn the steering wheel, and the original power steering pump recognizes that it's not giving enough torque to the that's when it kind of automatically revs up the engine. But anyway, these are the two valves that help breathe while idling. So this is first of all the idle control valve for Nissan engines. See, it's just a valve, air here and air here. And when you press on the throttle, this closes, so it doesn't give any extra air while at that time, and also when you hit boost, it doesn't bring back air this way. Then the another valve is this one, which is additional air control valve, and this has a small screw in it also, which you can adjust so that it gives automatically or manually air more to the engine constantly. And then there's a small tube here also, which controls how much the engine gets air. Now, both of these have their faults and good sides, but in a modern engine, as you can see how many wires these are connected. So there's a two valve system that controls how much the engine is getting air and how much it's not getting air in different kinds of situations. Very easy solution, just buy a Bosch unit. This is from a BMW, and basically how this works is that it has 12 volts in, and then these two are groundings, and these two you connect to the ECU, and another one says higher and another one says lower. And when you open the throttle, this closes completely. And this was €9 from Ovaco. So it's a used part, but these cannot go wrong. These don't fail. So as a spare part, it's a really cheap one, very easy to mount. It's a bit bulky, but you can mount it anywhere. And you don't have to connect this air intake anymore to your another air intake. So this can hang free under your intake manifold or even in your trunk if you want to, because this doesn't have to do anything with the MAP sensor as the original ones. So everything that connects air to the engine in the old system has to go through this one. But with the modern system like this, it doesn't have to. Then when we get to controlling your acceleration and your boost and cruising and everything, we get to the throttle body. So this is the vroom button. How much you open this, the more the engine gets air. And in a Nissan system, this is pretty complicated system. Also in my Supra, I have another throttle body, but the throttle position sensor here is the stock one. And these are pretty complicated systems in these old engines. Like calibrating this one is a bit tricky, and also calibrating the Nissan one is a bit tricky. And I can show you the original sensor. It's this one, and as you can see, there's a small opening, small hole in the back of it, and this rotates as the throttle plate moves. And this has two plugs in it. Now the first one is 3 pins, and this one is the actual throttle position that tells from 0 to 5 volts when the throttle body is open, close, or anything in between. And then there's another plug for some reason, which is also additional 3 plugs or 3 pins, and this tells the ECU when the throttle is fully closed or when it is fully open. And I have no idea why that is so, but this is a very old, complicated system. It has to be also adjusted. So as you can see, these are not holes, they are slots. So you have to turn it and find the right position to know when the engine is in, or the throttle body, throttle plate sensor is in the correct position. Now, in a modern engine, as the ECU master ECU, you can replace all of this with one sensor. So this is a Bosch unit, and it only has grounding, 5 volts in, and signal. And how to mount this to an RB20 DET engine throttle position sensor is that these both sensors have the same diameter hole in the bottom, which has this kind of slot machined away from it. This is an 8mm diameter, and this is a generic diameter for throttle position sensors, and you replace the sensor with this one, and the throttle body just needs a small adapter plate such as this one, which I 3D printed. I modeled it myself and 3D printed, and I'm gonna manufacture this from aluminum later on with a CNC machine, but first I made the prototype from this 3D printing material, but I'm gonna make this billet aluminum once I'm definitely sure of the design, and now actually I am, so I can show you. Just drop the screws off, and here it's there. Now it's in correct position. It's connected to the shaft, and when I move the shaft, the sensor reads. And another thing with these ECUs, you can just calibrate it. You can tell the ECU that in this position the throttle is closed, and when you press the gas completely to the floor, you tell the ECU now it's full, and the ECU learns that. So then the final thing of this video, that's how the ECU knows when to ignite the spark, when should the engine fire, and when should it give fuel to each cylinder. Now, these old engines run systems called wasted spark, and they run batched injectors, which means that the engine or the ECU actually doesn't even know when or what's the position of this engine all the time. Oftentimes it thinks it as 180 degrees rotation, when actually it's 360. And it just gives fuel in all possible situations, just to be safe. And it gives, every time the piston goes to the top dead center, it gives also ignition, even when the exhaust valve is open. So it's just a safety precaution, I think. And in the 80s, when they designed these cars, the ECUs, well, it was a simple task to do it that way. But nowadays, when we are a bit more maybe clever, our ECUs are more efficient also, and we can remove these old systems by controlling the timing of the engine and telling the ECU what position is of the from the camshafts and crankshafts like with 100% efficiency. The old system that recognizes from the engine is called a cam position sensor, and it's this bulky thing right here. This huge aluminium thingy is one of the most problematic things in these old Nissan engines. Once I have broke one of these, and these are not cheap to replace because you cannot get these anymore from anywhere. And I have explained it on another video also how these work. There's a plate inside of here, and which is rotated from this axle. This axle is physically in contact to your camshaft, to your exhaust camshaft, and when this rotates, there is a LED diode inside of here and a small plate which has these small holes in it, and in different kinds of situations the LED flashes through the plate, and there's another sensor that reads the flashing of the LED light through the plate, and it knows from the certain kind of pattern of these holes which position the engine is in. And there are two signal wires from this device here. It has 12 volts in grounding and two sensors which tell the ECU when the engine is in 120 degrees and when it's in 0 degrees from the top dead center. And as you can see, this also has grooves in it. It has to be adjusted very carefully to adjust the timing of the engine. And with this engine, the place for that cam position sensor is right here behind this, or replacing this cover right here. As you can see, I have the another kind of system here going on at the moment, but those cam angle sensors are very problematic, and I cannot think of anything more complex than those. In the Supra engine, it's also pretty much the same. This is the Supra version of the cam angle sensor, and it's also reading from the exhaust camshaft, and this works maybe a bit better than the Nissan one. But with a modern system, you can replace this whole thing with this. This is an inductive sensor which reads from the cam gear. On the top of the cam gear there's a grooved slot metal piece, and this reads the metal piece. And this is not the same kind of, exactly the same kind of sensor that I have in my car. This one doesn't have a shielding. Well, it's only this amount of wiring that's not shielded, but I wanted to make sure that my sensor has the shielded cable. But anyway, like I said, this is an inductive sensor. It only has a grounding and sensor, so this doesn't even require to have current in it. It doesn't require to have any kind of electrical connection to it. It sends the signal from contacting metal. As you can see, it's magnetic. See, it's magnetic, and when you pull, the sensor sends a signal, and yeah, it removes also the mechanical connection from the sensor to the engine. It reads it like Bluetooth because it's inductive, and it gets rid of all these problems that we have with these sensors. And since I have been running these kinds of Bosch electronics, this is a Bosch unit that I have on the engine right here. Ever since I have been running these sensors on the engine, the signals are completely 100% pure. There's no distractions, there's nothing. But with these older ones, when you were looking at the crankshaft signals with the timing light, you could see that there was kind of deviation and variation in the signal also. But with these kinds of systems, even when you get to 8,000 RPM, it doesn't get disturbed at all. So these sensors are rated up to 15,000 RPM. So if this engine revs up to 8,000, it's nothing to this sensor. It's like child's play. But with these kinds of systems, you can really get rid of these old sensors and make your life much more easy. Another thing that I could talk about for the whole day is the old systems for spark. So the old electronics in these cars, they run a separate box for ignition. It's what is called igniter. The igniter is a box between ECU and the coils, and it tells from the ECU, it separates the signal which cylinder needs to spark at which time. And I have never understood completely why these engines require an igniter box, because nowadays we have these smart coil on plug systems. These are from NGK. It's a system as easy as this. There's just 4 wires in, which is 2 groundings, 12 volts and signal. And you just place this on the plug like this, and this one costs around 23 euros brand new, and it's a really strong unit. I have never had this break. But if you want to take a look at the old ones, this is the old coil system for an RB engine, and these are dirty expensive if you break one of these. It's like 200 euros a piece, and it's ridiculous how complicated these systems were back in the day. I mean, the amount of wiring and all the boxes and relays and everything like that, it's very difficult to work with these old cars if you want to keep them completely stock. But when you decide that you want to make your engine run very safe and just make your life much easier, it's pretty simple. Also, the topics that I haven't discussed on this video is that I'm running a wideband sensor for the AFR, so the O2 sensor in the exhaust, that's also a wideband sensor. It gives much more wider band of AFR readings from the exhaust than the stock sensors that these cars have, and the stock units usually they tell like from 0 to 1 volts, but these wideband sensors tell from 0 to 5 volts, so that's much more wider range. One thing also about the wideband sensors that I didn't mention but I am running is the wideband knock sensors. So these engines, these old engines, they have knock sensors also. And if you know the basic principle how knock sensors work in these kind of engines, it's pretty simple. It's reaching it's adding fuel to the fuel maps or reducing it, and yeah, that's also a narrow band system that is with the old style knock sensors. But you can buy wideband knock sensors also for 30 euros a piece, and the engine requires 2 knock sensors, and you get much more information from those wideband knock sensors than you get from these old style knock sensors. Then the final topic, which has nothing to do with the ECU or anything, but it's the joy of making your car good one. So working with these old electronics is that these are oxidized very often. These are old and crusty, and these have these kind of batch jobs that I have also, which I've done myself previously, and these would work probably for some time. And the good thing maybe about these old sensors is that they are not very prone for disturbance. Maybe they are, but they are kind of rough around the edges, so they don't require that much shielding, and the signals don't have to be that pure as with the new systems. But like for myself, I have bought this is a 20-meter reel of signal wire. And what kind of signal wire this is the perfect kind of wire for signal that you can buy with money, because as you can see, I'm going to zoom in here. As you can see, this has a rubber outside, then it has a metal shield inside which you ground separately, and this protects the signal inside perfectly. And this is tinned copper, so this is not just any metal, this is copper. So it's a very good shield for any signal. It's the same kind of wire that they use for microphones and audio settings in hi-fi studios, so you know that the signal is perfect when it comes to hi-fi studios. And inside of the cable there's another shield. It's a nylon sock here, and then there's one more tube which is I think it's PTFE, which is very high resistant for temperatures and that kind of stuff. And then there's 0.75 square millimeter copper wire inside, which is the perfect size for all kinds of signals that you can get in audio or car systems that has to do anything with any kind of signal transportation. And I'm using this wire everywhere, especially for these kind of systems. And this is not that critical because it's controlling only idle, and it reads idle from the RPM, so it's not that critical. But everything that has to do with adjusting the engine is better to run it safe. Now, I hope I have given you a good idea of what this engine is about to become when I'm adjusting and adding all of these modern technologies to this old engine. It's just trying to make everything simple and safe and easy to maintain. Because, like I said, these are hundreds of euros a piece if you want to keep the engine as complicated and old and expensive as it is in stock form. This is 60 euros brand new, the Bosch sensor that replaces this one. This was 20 euros, this was 9 euros. And the throttle position sensor was 30 euros, brand new Bosch electronics. And this is so simple and beautiful. So, I hope you like this video. I hope you like this kind of videos that explain stuff in very ground level. And I'll see you in the next one. Have a good day.